My name is Samantha Rakela. I graduated with a Bachelor of Science in Chemistry from Florida International University this past December, and I'm part of the 2019 University of Florida SURF cohort with the Department of Pharmacodynamics in the College of Pharmacy. So to seeing this make you kind of feel like you want one of these? If so, there's probably a neuronal ensemble responsible, or at least that's what we theorize. This past summer, I've been working in the lab of Dr. Brandon Warren, studying neuronal ensembles. A neuronal ensemble is, very generally, a subset of neurons that gets activated during a brain function, and they're thought to be how our brain stores memories. So let's say something happens, like you see giant yellow arches, and then someone gives you a hamburger. These two events are activating different subsets of neurons, possibly all across your brain. If this sequence of events happens again and again and again, the neurons selectively activated by each separate event start to associate with each other. With repetition, these new neuronal connections become where the association between the McDonald's logo, your cue, and a hamburger, your reinforcer, is stored, the neuronal ensemble. My project was meant to determine whether projections from neurons in the thalamus, specifically the mediodorsal thalamus, to neurons in the nucleus accumbens, were involved in the acquisition of food-seeking memories. We wanted to see whether neurons going from the thalamus to the accumbens were preferentially active when trained rats were using the so-called neuronal ensemble to recall that when they pressed a lever, a light went on, and then they got food. This would tell us if these thalamic neurons projecting to the accumbens might be a part of the neuronal ensemble responsible for the food-seeking memory. First, we tagged every neuron in the thalamus that projected to the accumbens with either a green or red fluorescent marker. We tagged different hemispheres with different colors so we could tell which projections were projecting ipsilaterally, or originating from the same side of the brain that we were observing, from neurons projecting contralaterally, or originating from the opposite side of the brain than we were observing. Then we subjected trained rats to a short induction test, in which they could press a lever that activated a cue, but no food reward followed. We tagged neurons that were activating repeatedly during this test with a different fluorescent marker. We could then determine the number of active neurons that are also projecting from the thalamus to the accumbens in rats who had learned this association and those who had not, as well as compare between the two brain hemispheres. I did a lot of this. So, spoiler alert, projections from the thalamus to the accumbens didn't seem to activate preferentially when rats were recalling this taught food-seeking association. There were significantly more active neurons in the thalamus during induction testing, although there was no significant difference in this activity between learners and non-learners. And there were significant behavioral differences during induction testing between rats who had learned and those who hadn't. So, what does this mean? It could mean that thalamic neurons projecting to the accumbens aren't a part of the neuronal ensemble encoding food seeking. Or, it could mean they just aren't involved in acquisition specifically, but may come into play later on in the process. Either way, the more we learn about how and where associations are stored in the brain, the better chance we have of understanding how harmful associations, like drug addiction, form, and the better chance we have of finding ways to prevent, combat, or remedy them. I want to thank Dr. Brandon Warren and my mentors Richard Quintana Feliciano and Dr. Christina Gobin, as well as all the other wonderful people in the Warren Lab that time restraints won't permit me to name, for being so kind, knowledgeable, and welcoming, and making this such a memorable experience. I also want to thank UF for funding the program, and Mike Nazareth, Julissa Nunez, and Brittany Boyer for all working tirelessly to make SURF happen. I know I mostly talked about my time spent on research, but the SURF program is full of many things besides it, like weekend museum trips, hiking, and free ice cream. I also had plenty of opportunities to talk to graduate students and get application advice, as well as perspective on what it was like to be a graduate student in general, which I would say was invaluable in informing any decision I made about graduate studies. All said and done, I plan to apply to UF this coming academic year for entrance into a PhD program in pharmaceutical sciences. That's it for me for now, and maybe I'll see you around.